we are here for Community Conversations, our Technomatics virtual user group once again. And our topic for today is cost simulation using user-defined attributes. Our speaker for today, as usual, is Mr. Steffen Bangsow, and he is a freelance simulation expert and has been for several years now. He's done hundreds of projects and training sessions, and I think we're almost at 50 sessions for PLM here with us as well. He has 5 books on plant simulation and is one of the leading contributors to our Siemens PLM community, and he is one of our community catalysts as well. For today's agenda, these are the 3 big steps that you'll see. Steffen is going to show how to build and apply cost functions, how to define and manage costs, and then how to perform custom cost analysis. So as mentioned, he'll be presenting this live in the software, and then we'll do the Q&A at the end via hand raise or via the chat. So that's all for my intro. Steffen, feel free to take the screen.
Hello. Today I want to show some topics for cost simulation, and first some information around this. At the first step, I create a very simple model here. I want to have a source, and then 2 stations, and 1 train. And I want to show you 2 different ways of cost simulation. First, the built-in cost simulation with the CostAnalyzer. The problem is the CostAnalyzer is only available for the professional license and advanced, also Plant Simulation X Advanced. For the other license types, you need to program the cost analyzing by yourself. As a first step, you need to set the currency you want to use, and this you can do with file model settings, and then you have units, and here you need to set your currency. You see you have several currencies here, not as much as countries where Plant Simulation is using, but you need to set here the currency because the cost simulation is done with the data type currency, and so you need to set up here your currency in the model settings. This is the first step. The second step, the cost simulation is here in Plant Simulation since version 15. This was the starting point for cost simulation and Plant Simulation. And we can set some information in the MU in the part here. Open the part, please. And then you have 1 tab costs. Please activate this. And then you can set here the material costs for the parts. I only use 1 part here. And maybe it's 50 euro. This is the material costs per piece. Second part of the cost information you find in the stations or parallel station in many of these active material flow elements. All this has a costs tab, and I hope you can give me a thumb up if you can activate the cost tab. Also, if you don't have a professional license. Okay. Okay, please try the following. Open the station and activate the cost tab. And there you have three information for calculate costs here in plan simulation. The first one is investment costs. And the investment costs distributed over a certain depreciation period. And then you have operation costs. And the operation costs is all all that you want to integrate in this cost calculation. Maybe a rent for the place where the machine is, or the parts of the equipment or facility costs, or also the costs for the worker, because the worker itself, if you can see this here, the worker itself don't have a costs information here, and so it's difficult. You need to create all this by your own if you want to consider also the personnel costs. Okay, so you have two steps to do if you want to include the cost information here in plan simulation. You need to assign the material costs to the parts, and then you need to activate the cost tab or the cost simulation for all the elements you want to calculate the costs here. I want to calculate the cost for the stations, and there we need to set some costs here. For the first station, first I want to have a cycle processing time of 1 hour. And I want to have a depreciation period of 10 years. Investment cost of 2.5 million euro. Or 2 million euro. And operating costs, including all the personnel costs of 25,000 euro. For the first machine, and for the second machine, the same 1 hour processing time. A 10-year depreciation period, 500,000 euro. Investment costs, and 35,000 euro operating costs per year. Okay, now we need to set an end for the simulation, maybe 10 days. And then we should be able to run the simulations. Nothing special here in this simulation. And for analyzing the costs, you have an instrument. It's in user interface. And if you have the professional or advanced license, you should be able to input the CostAnalyzer here. And then we need to restart the simulation. And the CostAnalyzer only collects data. You can open this this CostAnalyzer and you find two different calculations. The first one is investment costs. You'll find here the total investment costs for the complete model, and then all the investment cost information you have entered into the cost tabs. And you have a calculation of the cost, piece costs, but here you need to be very carefully because there is not really clear how Plan Simulation is calculating this. And we will calculate this in a different way. So the piece costs consists of material costs and then accurate costs, and this is not available for us to address this as attribute in Plan Simulation. And also general costs, no idea how they calculate this. So, but this is the standard, and this you can track into HTML. So you can take this. You can take the HTML report if you have the license for this, and then you can just track the worker pool. It's a lot of comments here, and I make place here, and then you can track the cost analyzer here into the HTML report, and then you can find the cost information here in the HTML report here. It's quite easy. But really, you need to be carefully with the piece costs, because first you need to ask your company how they want to calculate this. And normally piece costs consist of material costs and personnel costs as direct costs. So personnel costs is missing here. And then the machine costs are distributed to a certain number of utility hours per year. And this can be quite different if you have, for instance, one or a 3-shift production system. If you have a 3-shift production system, then the costs are distributed on much more hours per year than if you have a machine that's working only in 1 shift and only maybe with a utilization of 50% per year. And so you have much less, so you have less production hours, and the costs per hour for the machines will be much higher. And so it's better to calculate the piece cost by yourself. And this we make as a next step, also for all that don't have the CostAnalyzer, because they use another kind of license types here in Plan Simulation. Okay, to create our own production costs, we need to add some user-defined attributes first to the station, because for the station we need one more information for calculating the hourly rate for the cost for the machines. And so I opened the station in the class library, and I add a user-defined attribute for the average utility hours per year. So as an integer, and I set this fixed to maybe 1,320. To calculate the average hours per year for a machine, you can also use the simulation, but you should use an average value for calculation for the cost calculation. So you have one stable value for calculation the cost. You can make this with the shift calendar. If you assign a shift calendar to the to your model, the shift calendar has a method calculate working duration, and so you can calculate the working duration for 1 year, and as a second value for calculated the right average util hours per year, you need utilization of this machine, how many percent of the complete time the machine is really working. And using this two values, you can calculate a certain number of hours that the machine is working each year. And really, it's depend very heavily on the number of shifts you calculate, and if you're working on Saturday or Sunday. Okay, this is the first value we need. In addition to the cost information, plan simulation has already included here for us. And as a second one, the cost per part, we cannot access here using the attributes of the part, maybe because it's hidden because of the limitation of the CostAnalyzer, and so we need to define our own attribute for parts per piece here. And I want to have here in this part a user-defined attribute with the name production costs. And this is data type money, not currency. Money is the data type here. And you see here the currency you have set for your model. The initial value is 0. And this production cost we need to sum up during the production process, depend on the values we have set in the stations here. Okay, and so we need some controls now to fill this attribute. So the first one is in the source. We need to transfer the material cost to as a first value, as a first step to the production cost of the part. And so we need, for instance, an entrance control in the source. What's wrong? And here we set our production costs. And the first one is at point material cost per piece. This is an attribute of the part here. If you have a look here, it's defined so this is a defined attribute here in plant simulation, and so we can use this. And the first step is at the starting of the production, the costs is the material costs. And then we need an entrance control for all machines where we want to calculate the costs. And so I make here entrance control and assign this to the station. Hold down the Shift key, and if you drag the method to these stations, then it becomes automatically an entrance control. What we need to make here is we need to calculate the investment and operating costs per hour. We have here in our costs tab all we need to calculate this, but we need to divide the investment cost by the depreciation period to get the investment cost per year, and then we need to add the operation cost per year to get the information about the cost per year for the machine. And then we need to divide this by the average utility hours per year of the machine. And this we can multiply with the processing time of the machine and get a portion of costs of this part that we need to calculate to pay all our investment costs and the operation costs of the machine. And so we need to calculate at point production costs. So, and now we need some calculation. Investment costs and depreciation period are both attributes of the station. So investment costs divided by depreciation period. This is the hourly depreciation of this machine. We need to add the operation costs. Okay, more brackets, and this we divide by AV util hours per year. Okay, and this is hours here, and the base time unit in plant simulation is seconds, and so we need to divide this by 3600 to get the machine cost per second. And this I can multiply then by the proc time of the machine. And so I get the 7. You need to count the and so we calculate the now the production cost is for the first machine after the first machine the material cost of the part and the portion of the hourly costs of the machine. And so we can calculate this step by step for each machine. And at the end, we get the total production cost of this part. Okay, I check this. I create entrance control for the source, for the train. Just with a debug to stop the part when it's coming here. And then I start simulation. Deprecation period. There's a I missing here. It's operating costs. Sorry. Okay, it's depreciation, yeah, and it's operating costs. These are the attributes here in plan simulation for the cost functions. So now I have one part, and now I can have a look here, and my production cost is 284 euros after these two machines here. So, and now I need to rebuild the functions of this cost analyzer here for my simulation. If you don't have, okay, the cost analyzer shows a complete different piece cost because it distributes, I don't know, the the cost for the part without considering average hours per year. I guess it distributes complete per year. It's changed a little bit if you take the shift calendar here and place it for the machines. But I don't want to use this here. So, and now I want to make two statistics. The first one, it's very important for many projects. If you want to have the complete investments here in within a frame, then we can use the inheritance of the station to sum up all the investments we need. I guess you know this from the computer-aided design programs where you can create from a certain layout a bill of material with all the equipment you have placed there. And this we can also do very easily in plan simulation. I want to have two tables. The first table is invest. This invest table should contain all our stations. And the investment should be money again as a data type. I want to use the NSIM method to calculate all these investment costs are very, very important if you have to compare several scenarios where you have different machining, different machines, different equipment, and you need to compare the investment of both or of the variants. And so we need to calculate this, and we can do this also in plan simulation. You only need to define or place the information in the stations, and then we can extract this information, for instance, using the inheritance of plan simulation. Okay, my stations are inherited from this station here, so I can track this from the class library. And with num children, I can calculate the number of children of this class. With child no, I can access each child of this class. You can here have a look in the class library. Show inheritance shows you all the childs of this class, and here's one child in another frame. It's by default in my frame in user objects, and we need to exclude this frame from our calculation. And so we need to check the location of the stations. So we have only the stations in this frame. We can check the location, and the location should be the same like the NSIM method here, and this is the anonymous identifier current. And then I want to write one line in my invest table. And I want to write station name and the attribute where you store the investment costs. So that's it. And if you have other station and other objects here where you assign some investment information, then you just take the other classes, or you run through all elements in this frame, and there you have some methods, num node and node number, where you can access each element here in the frame and look for the right information. Okay, let's have a try here. So now I have my investment costs here for this frame, and then I want to have a total investment variable in the frame to have the investment sum or total investment of this frame. And so I make a global variable with total investment also as money. And I only need to sum up the second column in my table. The table provides a method sum, and I need to define the range I want to sum up, and it's the second column. And so I have the total investment sum here for this frame. This is the first step to analyze the costs, and the second one is product costs. I need a second and normally you have several parts here, and if you want to record the production costs per part, you can use a table with a row index, and here you have your part. This is the easiest way, and your production costs as money. And if the part is not in this table, you enter the part name as a key here in the row index, and then you can assign the production costs very easily. And you can do this in the entrance control of the train, for instance. If you want to have the total production costs of the part at the end. So to debug. You can use get row number to check if this is already in the table, this part name, and if it's not in the table, it returns -1, and then we need to add the name of this parts into the index of this table. With item index, you can read the number of rows in the index, and the next free line is then item index +1, and there I am writing at point name, and then this is the easiest way. You can also calculate the number of parts and total sum of production cost for this part type. And then you can calculate average value of production costs if you have rework, if you have different machines for the same part type. Then it's better to calculate the average value. But you can use the same approach to fill the production cost table. And now I have my production costs here. And if you had more different parts, then you had here a table with all the production costs. Okay. So using user-defined attributes, you can make this cost calculation more detailed. You can adjust this to the calculation scheme of the company. And this is the first thing you have to do. You need to acquire the calculation the company uses. There are so many different ways to calculate product costs. And the next problem is that all this information for calculating the costs are very secret and very confidential, and most companies don't give this data out to other, or the calculation department don't hand over this data to other departments, and so it's very hard to get real data. But the investment costs here, it's very easy to find. And if you make some, for instance, some changes in existing productions, then you can mark new equipment with a user-defined attribute, and then extract only the additional investments by changing production systems. But it's quite the same. You only need to check your user-defined attribute if this is a new equipment or old one, and then you can calculate also the total investment of certain variants of your models. Okay, that's it. You can extend this calculation, for instance, for using the personnel costs here. If you have importer for production, you can check, okay, how many worker I need and how long we need this worker, and then you can add personnel costs to the worker, and then calculate also the personnel costs or worker costs here for each step. Yes. Any questions? Okay. I think this calculation can be extended to take into account some expenses. For example, if machine fails during processing, it still consumes money. The same if station is idle or blocked. In CostAnalyzer, all these costs are distributed to appropriate parts. Yeah. The last line of my NSIM method, it's only this sum up of this invest sum. I guess I could fill a complete day with cost calculations because it's not so easy in reality. You have so many different ways to calculate for instance, machine cost rates. We do this here in Europe. We calculate machine cost rates, and this is quite a complicated calculation. You can find it in my book, but there are much more elements in this calculation. The same as how you calculate overall costs, the cost of the overhead or the cost of the facility. There are many ways to do this, and the same as how do we deal with empty or with starving costs of the machine. But really, you need to look in your companies, because there are so many different ways to calculate this, and you need to implement the same way the company is using this.
Other than entrance station, drain entrance, NSIM, yes. Any other methods are used in the model?
Yes, there's one entrance control in the source here. There's entrance control where we write the material costs into the production costs of the part. And drain entrance we have, and the entrance station is the entrance control of both of the stations. No other methods. So this is the entrance control of the source. It's only one line. Its production cost is material cost per piece, and material cost per piece is built-in attribute in the part. And this is the control, entrance control of the train, and this is the filling of the part cost table. What do you think about calculating part-related costs by processing Gantt table after simulation? Okay, it depends. You need to you have the link to the stations there. You have all the times. Yes, it's possible, I guess. Yeah.
Okay, I did want to show this. So if you're not familiar, you can click through that link that's on the screen right now. That will take you to the web page that's being shown, which is the Plant Simulation Virtual User Group. You can follow the topic there by clicking the button and selecting every post. We'll make sure that you get emails about the next session, about the recording when it's posted, or any questions that we post for you there. You can also click on those links, the next 2 meetings. So Wednesday, March 25th, we'll do worker batch processing. And then Wednesday, April 8th, it will be creating Gantt charts using a data table. So those are both registration links that you can click on now to register. And then very quickly, our team from Xcelerator Academy, you can click on the few links that are there. Would just like to let you know that these are the comprehensive courses available in that platform. And there's also a Plant Simulation Associate Certificate that you can do. And then, of course, Realize Live happens every year. If you're not familiar, we hold this in the Americas, this year in Detroit, in Europe, this year in Amsterdam, and in India, in Bangalore. So you can definitely click on the links there if you're interested in attending. This is our customer event for Siemens PLM, and there's still a discount available. I will be there, Steffen will be there, some of our other community catalysts will be at these locations. So definitely attend if you can.
So your next question is, can you talk about your next book publication? Will this be Technomatic Blank Simulation 3rd edition? Yes, it will be the Technomatic Blank Simulation 3rd edition. I deleted all 2D stuff since Blank Simulation, I guess 2606 this year will not support 2D anymore. And so I deleted all the content for 2D, and I actually I updated the book to version 2504 with a lot of new examples. Okay, the next one. How can cost analyzers and plant simulation add additional value for companies that already calculate costs using the cost accounting controlling module in their ERP system. Okay, we are make normally some new. Okay, it depends on the objective of your simulation. If the objective of the simulation is, for instance, reducing the production costs per part, then you will need to show the production cost per part in your simulation. And the same as if you have to compare several scenarios based on investment costs, then you need to include investment costs in your simulation. And you have in your ERP system only the calculation of your current system, but not of for future systems that could look quite differently. And so, yes, it can give some additional value for the companies, and it's really depend on the objectives of your simulation.
Hi.
Yes.
Hi.
The question I have is like, I want like normally in manufacturing plants we used to have the pallet tray during especially during the packaging and kind of situations, packaging and palletizing. So what I want is I have a two source incoming to a station. So I want to first customize the filling. Like imagine there's a 2x2 like a kind of table. I have a part A and part B coming. Like part B being the base, like a pallet, and part A being the actual part being assembled. So I want to assemble on the top. First, I want to fill the layer, and then I want to just stack up one another. So there is two stations, like station 1, station A, and station B. On station A, I want to fill it on the base, and station B, I want to like stack the already product made from station A. So I'm not able to do that. So do you think is it possible in a plant simulation to do that, like a kind of customized assembly, or we don't have any option on that? Okay.
Okay, you can only attach parts on the main part,
Okay.
but not directly on the part on the main part. And if you want to do this, then you need to use SimTalk. You can easily move parts on, for instance, at.cont on the content of a part, and move the part on this, but not directly with the assembly station.
Okay.
But it's really easy with SimTalk.
Okay. Yeah. Again, I get it. Okay.
Otherwise, it's all parts are located on the main part on the same level if you want, and so you can have a main part with a big capacity, and then move at the first station only one part to the main part, then move it to the next station, move another part on the main part, but then it's located all on the main part and not on the part on the main part.
Okay, I have a part, I have a container. So I define the container's XYZ dimension as like 2, 2, and 2. I want to first fill the base, and imagine a situation where I want to, for example, I have input A, input 1 and 2 going into station A. So I assemble the part, a base, a container, and the part. So next it goes to a single station. So in the second station, station B, my input is just 1. Now I want to stack the output of station A one upon another. So at that time, the station B consider the XYZ dimensions of container, which is like predefined for station A. So it's unable to stack one upon another. So is there any solution?
Yeah, you need one free place on the main station where you stack the part, and then you can move the next container on this free place. But then you need to address the place there, the free place with PE, for instance. And then you can move directly the part there, because there is no real stacking in plan simulation. You can stack on a container if you have a virtual container on the base with capacity with X and Y 1 and then Z 10. Then you can place all the parts on this virtual container, and so you can stack based on a virtual container. But you cannot stack easily on the same container, another container.
Okay. You mean I need to create a duplicate one and consider it as a base, like a container?
Yeah, but you can make an invisible container just as a stack. The container you don't see, but you can place all this stuff on the container, and sometimes we need a dummy. For doing this, and this is the easiest way.
Okay, get it. Thank you so much.
Okay. So thank you. Until next time.
Yes, we'll see you guys in the forums. Bye.
Goodbye.